Hello everyone, welcome back to MAT1033. So before we start the new concept, I just want to do a quick recall on the concept we already learned. I don't know how long ago, maybe you guys, when you guys took MAT28 and you guys had learned this concept already. The one I'm talking about now is a power number. So let's do a quick recall what power numbers first, okay? Then we'll go from there. So recall. So what is power number? What is power number? Alright, so if you multiply a number by n time, so we can rewrite that numbers in another form. In another form, we call it exponential form, right? For example, I want to multiply 2 by 2 by 2, and I can rewrite it as 2 to the third power, right? 2 to the third power, because we multiply 2 3 times, multiply each other 3 times, right? And if I multiply just think about if I want to multiply a number a, right? I want to multiply a number a, okay, n time, okay, multiply a number. So I can write it as a to the n power. So this is called power number, okay. This is called power number. So 2 to the third is a power number. A to the n is also, a over here is a number, okay. It's not a variable. So a to the n is also the power number, and because this is raised to the n, the n could be anything you want, okay, because over here I don't know, so this is a multiply n time, okay, n time, okay. So the a over here, the a over here, back in the day we call that the base, right? We call the base, right? So I mean, in MAT28 we already talked about it, so we call this the base, and the n right here we call that the exponent. Okay, so we can create a power number easily. Okay, if you just go ahead and take a number, you multiply by a certain number of times, then you can create a power number. Okay, now I want to change the base over here, okay, because last time I said the base could be any number, right? So now if I go ahead and change the base here, and I change and replace the base here, a number over here, the base, with a variable, okay, with a variable. So okay, let's go ahead and change it. So let me use a different color to change it. So if I go ahead and change the a over here, and I changed it to x to the n, okay, x to the n, x to the n. Okay, so what I have, so the x over here, is the variable. The base in this case is the variable, right? It's the variable. Okay, it's still the variable. Oops, oops. Sorry, it's kind of frozen. I'm sorry. Okay, it's the base over here. The base over here is a variable, so it changes it, right? The n over here is still the exponent. The n over here could be the n in this case, or in this case is the n is the positive or negative integer. Okay, positive or negative integer. Okay, so it could be negative integer or positive integer. So if I go ahead and change the base here to the variable, so the base in this case the variable, so what I just create is not just a power number. Okay, what I just create, we call that exponential expression. So in this section, in this video I want to focus on what exponential is, and we're gonna talk about the definition of exponential, and we learn how to simplify exponential expression. What would be exponential expression look like? Okay, so and how we're gonna simplify exponential expression. Okay, so let's get started with our new topic today. So I'm gonna put over here exponential expression. So first of all, exponential expression is algebraic expression. So first of all, let's talk about definition. Okay, it is algebraic expression. Algebraic expression. Okay. Okay, but it's not just a regular algebraic expression. Remember, when we talk about algebraic expression, we talk about a constant term and a variable term, right? So this algebraic expression is variable term. Well, if you want to add it, if you want to add a constant term to that, that's fine. But the variable term here must be in exponential form. So variable term, okay, is in exponential form. Okay, so it's in exponential form. So exponential form is a power number form, but instead the base instead of being a number, the base is the variable. So that's why we call the exponential form. And again, the exponent could be positive or negative integer if you want to. Okay, let me give you a quick example of what exponential expression look like. So I can have something like this. For example, I have something really simple like this. X squared. Okay, so this x squared over here is an exponential expression. Or I can have something more complicated. What if I have like so this one is nothing but the variable term, right? Because it's a variable, right? Or I can have something with two variables. For example, I have a x squared, y to the third. So this is also exponential expression, okay? Or you can put in exponent. You can use the negative exponent if you want to. For example, I have a negative 3x to the negative 3. Y squared z to the negative 1. So this is also exponential expression. So the number in the front over here we call that coefficient. Okay, so over here we call coefficient. So let me use a different color for that. So this is called coefficient. Okay, this coefficient, and the coefficient over here is negative 3, and it's nothing to do with the exponent. Okay, so the exponent for the x is negative 3, the exponent for the y is 2, and the exponent for the z is negative 1. So it could be in this form also, or it could be in fractional form if I want to. For example, I have 5x squared y 6 z to negative 3 over 15 x negative 1 y to the 7 z4. Okay, this is also exponential expression. Okay, but it's just in fractional form. Of course, it's more complicated than this one, right? And this is more complicated than this. This the one right here. The simplest one is look like this. Okay. Okay, and again over here we have 15 as is also the coefficient, and it's nothing to do with the exponent. And if you see that the exponent could be positive and negative, okay, we don't have later on the exponent could be in rational form. Okay, however at this moment it must be it must be the integer, okay, whole integer, okay. But later on it could be like this. It could be like 2x to the half. Okay, so the exponent over here is a half, and y to the negative 3 over 2. Okay, it could be like this. It is also exponential expression. Okay, And I just want you to be careful a little bit over here when you write exponential expression, especially when you write the exponent. So the exponent you have to raise a little bit higher than usual, and the exponent try to write smaller than the variable. Okay, so in this case you should write kind of big, so that's just not good. The reason I want you to do that because it's very easy to get careless mistake with exponential expression. Okay, and maybe some of you ask me that, do we have a zero as the exponential as the exponent? Yeah, the answer is yes. We also have zero as the exponent. Okay, but we barely have like I mean, like 2 raised to the 1.0333333. We don't have such thing. Okay, I mean, we might have the rational exponent, but like decimal one, like the irrational one, then we don't have it. For example, I have like x raised to the e. I mean, it's not that big. That could be also exponential, but you barely see it. It might be called exponential expression also. Okay, so it depends on the level. So at this level, when you talk about intermediate algebra, I don't want to go too much into the exponent when they have irrational and rational and irrational exponents. We just focus on something like this. Okay, but maybe at the end of the semester we have something with rational exponent. Okay. Okay, so after we learn what exponential expression look like. So on the second part, I want to talk about how we're going to simplify it. You know, back in the day when first time we learned algebraic expression, and the way we simplify algebraic expression, we combining like term, right? And we know if it's a similar term, we can combine them. Okay. If it's not the same term, then we cannot combine. For example, 2x plus 3x we can combine, but if it's 2x plus 3y, we cannot combine it. Okay, actually that concept could be applied over here also. But other than that, in order to simplify exponential expression, especially the one in rational form here, we have to use some property, and you have to memorize all the property here. So the first property is we use this one. I want you to memorize all of this because it's very important. So the first one is, if you raise anything, okay, in this case the variable x, you raise it to the 0. So you just ask me what if we, or whether or not we have 0 as the exponent. Yes, in this case we do, right? So we always do. I mean, if the question gives you the 0 as the exponent, so if you raise anything to the 0 exponent, right, 0 power, right? So this is turned out to be 1 on the term. Okay, it turned out to be 1 on the. We have a proof for that, but we're not going to go go to the proof because this is not an analysis course. So we'll just go ahead and take it for granted. So anything raised to the 0 turned out to be 1. Okay, and the second formula there, you have. If you have variable x and you raised it to the n and everything raised to the m, then this is turned out to be x raised to the n times m. Okay, so it's very important formula. Formula number 3 is that if you have two exponent expression with the same base, so x to the m, you multiply by x to the n. So you see that the base is the same. So in this case, we have x to the m plus n. Okay, so I'm writing very carefully. You know, I write the exponent really small so that you can see. Okay, m and n is our exponent, not just the base. Okay, it's not the base. And if you divide two power number with the same base, so let me think something like this. If you divide two power number with the same by x, then it becomes subtraction. Okay, it's very important. Okay, number 5. And if you have everything, if you have a product, okay, if you have a product A between A and B and you raise it to the n power, then each of them will be raised to the n power. Okay, the same thing for the quotient. If you have a quotient, okay, raised to the n power, then each of them can be raised to the n power. Okay, and this concept is not working for the addition. Okay, because some of you do like this. Some of you put like this, a plus b raised to the n, and it turned out to be a to the n plus b to the n. We don't have this formula, okay? We don't have this, all right? So you have to be careful. We have the product, we have the quotient. We don't have addition and subtraction, okay? So you cannot apply. So this is a very common mistake, okay? So you have to be careful right here, okay? Number 8. Okay, number 8. If you have a negative exponent, okay, then I mean, if you keep your final answer as the negative exponent, it's not wrong, but it's just not nice. Okay, so if you have a negative exponent, you can flip over to become a positive exponent. Okay, and if the negative exponent is under the denominator, something like this, you can flip them up so that it become a positive exponent. You always want to keep positive exponent. You always want to keep positive exponent all the time. Okay, you don't want to keep like negative exponent. All right. So let's see what else. Alright, so this is the very basic 8 formula. Okay, this is a property here, and you have to memorize it. This is gonna follow you. I don't know, until you finish all the math course. So please memorize, because you don't want to forget, especially the second one. Okay, especially the second one and the third one. Right? And I mean, all of them should be very important. You cannot forget. You're not allowed to. You have to memorize all of this. Okay, and how we're gonna memorize it? We're gonna do a lot of example. Okay, so let me start with something really simple first. Okay, and let's see how we're gonna apply this property here to simplify exponential expression. Okay, so let's start with example number 1 here. Alright, so what if I have x, okay, I have x, y, z, okay, and I raise it to the 0, okay. It doesn't matter, okay, what are inside. You see that the parentheses cover everything here, so it means that everything raised to the 0, the whole thing, so it turned out to be 1. Okay, even you have a very complicated one. For example, I have like negative 4x squared y 3z over 7x to negative 1z negative 4 y 2, and you raise this to the 0. It's always turn out to be 1 no matter what. Okay, so the parenthesis is very important. If the parenthesis cover everything, it means everything that thing considered as one part, and one part raised to the 0, it turned out to be 1. Okay, however, if there's the parenthesis over here, it just cover a part of it. Okay, it just covered a part of it. Then we just the 0 exponent can be applied to that part only. So we're gonna do more example when we get to example, maybe example 7 or example 6. Okay, now let me give you something, example number 2 here. What if I have something really simple for us? Okay, I have x squared raised to the 3rd power, then it become x to the 6, because 2 times 3, I apply the second formula here. 2 times 3 is 6. Okay, 2 times 3 is 6. And what if you have like negative exponent, like negative 2 and negative 4, and you're gonna do the same thing. So you're gonna do negative 2 times negative 4. x to the 8. Okay, if it is positive, then okay, it turn out to be negative exponent. Okay, and when we have negative exponent, we have to you have to bring it to positive exponent. Okay. Alright, let me give you another one, something simple using the third and the fourth formula. What if I have x to the third power multiplied by y to the negative 5? Okay, then can we do this or not? Oh, because the base not the same, right? So if the base not the same, we cannot do anything. We cannot simplify this. So this is not working. Okay, so this is I'm gonna put over here DNA over here does not exist. That means that we don't have the simplified form. However, if we have x to the third and you multiply we have by x to the negative 5, then it turns out to be you add them up, right? You add them up 3 and negative 5, so you add them will give you negative 2. And now what we have is the negative exponent. We can apply the final formula here, the final property here, and we can flip it over. Then it become positive. Okay, so flip it. This is on numerator. You flip it down to the denominator part. Then it become positive, right? Right. And you do the same thing for division. What if I have like, let me use a different variable. Let me use the y to the negative 5 over y to the negative 4. Okay, then it becomes y to the negative 7. Okay, y to negative 7, sorry, minus, right, subtraction, because according to the formula is subtraction, minus 4, minus 4, right? Because the second, the n over here is minus, so it become what? Become y to the negative 7 plus 4. Then it turn out to be y to the negative 3. And now we apply the last formula here, so it become 1 over y to the third power. Okay. I mean, some of you want to flip to positive right away. I mean, you can do that also. Okay, you can do that. So you can flip it. You can flip negative 7 down to become positive. You can apply the 8 formula right here and flip that up and become positive. So you can do that one. There's another approach to simplify a rational expression. Okay. All right. Now let's do something something harder. What if I have something like this? I have negative 4 x squared y negative 2 z 5 over 16. Okay, x negative 1 y 6. Okay, z negative 2. Okay, how about this? How are we going to do this? That's okay. First of all, we have to simplify the coefficient first. So 4 and 16, if we go ahead and simplify, so become negative 1 over 4, right? Now we're going to do this one because this is look like we can use this one, right? Because this quotient is for the x, the same base over here, the x. So it'll be 2 minus will become x to the third, right? Because 2 minus 1 and negative 2 minus 6, right? So become y to negative 8, right? 5 minus 2 then become z7, right? So using the fourth formula right here for x, y, and z. But however, when you apply this formula for the y, it turns out to be negative exponent for the y's. Then go ahead and flip it down. Remember, the 4 is already under the denominator, so on the top we will have negative. It's still on the top, x to the third, z7. And the bottom we will have 4, right? Because 4 in the denominator already. And now we're gonna flip this one under denominator also, so become y8. So this will be your final answer. Okay, that will be your final answer. All right. Now let's do another one. Let's do another one. Okay, so let's do something more complicated. Example number 5, when we have something raised to the 0, but not just a part of it. Okay, not everything, because in the first example you see that I have everything raised to the 0. How about this one, example number 6? Okay, what if I have x to the second? Okay, raised to the third, y to the -2, z to the 4, everything raised to the -1 over, oh, this is kind of complicated, right? It's over 2x raised to the 0, y 5, z to the -2, and everything here raised to -3. All right. So how about this one? This one is more complicated than the previous one, right? So first of all, we see that over here, you see the whole part over here, everything over here inside parentheses, everything turned out to be 0. So it turned out to be 1 because over here the exponent is 0, right? So I can rewrite it as, so I'm not rushing, okay? So let me deal with it one by one, part by part. So I have x squared raised to the third power. Then I have y to the -2, then z to the 4, by everything raised to the -1, and at the bottom I just go ahead and throw this away because this is turned out to be 1. So what I have is just y to the 5th, z to the -2, and everything raised to the -3. Alright, now we're gonna do a one by one inside. Okay, so first of all, I can go ahead and apply the second property right here for this part, and so this will become x to the 6, right? Because 2 times 3 is 6, y to the -2, z to the 4, everything raised to -1. Okay. And over here, I can apply -3 to each of them, right? So I can use the second property also for the bottom. So become 5 times -3, so it's y to the -15. And z to the -2 times -3 will be +6, right? Alright. And we also apply -1 to each of them. So I have x to the -6. Okay. -2, -1, -2, -1 give you +2, so you have y to the +2, and you have z to the 4 times -1 over here, so apply each of them, so give you z to -4. There you go, over. So you see that I applied the second property many times, right? It's very important property right here. Okay, very important. So over here at the bottom we have y to the -15 and z to the 6. Alright, so now we can go ahead and apply the quotient rule for this, because this is the same base y over here. The x to the -6, I'm just go ahead and keep it for the time being. So that over here I subtract, it will be 2 minus 15 give you y to the 17, right? Because 2 minus 15 according to the rule, right? We have minus of the end, and the end over here is -15, so it becomes 17. And the same thing over here, we have z to the minus is -10. Alright, because -4 minus 6. However, if we have the negative exponent, we gotta flip over to get the positive exponent, right? So my final answer will be y to the 17 will be on the top because it's positive already. However, this is negative. We will flip it down to the denominator, so it will become x6 and z10. Here you go. So you flip everything. You flip the -1 to the denominator to be to get it positive one. So this will be final answer. Okay, so this is more complicated one. So maybe on the test I'm gonna give you something like this. I'm not gonna give you something like this. This is too easy. Oh, this is too easy. Everybody can do it. Alright? This is MAT28. It's not a 1033. Okay. Now let me give you another one. Okay. How about this one? This is maybe more complicated than this one also. So I'm gonna give you example number 7 right here. Okay, so I'm gonna have something like this. So I have exponential expression, and we have 4x negative 2, y negative 3, t to the 5 over negative 2 x 4 square, okay, y2 square, okay, and t to the negative 1, and this is multiplied with another one. Okay, so another one over here will be 5, and over here will be 15, right? And over here we're gonna have t to the negative 2 square, okay. And on top, I'm going to have y to the negative 2 raised to the 4 power. And over here, I have x to the negative 3 power, negative 3rd power. There you go, something like that. It's kind of complicated one right here, right? Alright, and maybe if I want to add a little bit more something, maybe I have something raised to that. Over here I'm going to have a zt square and everything raised to the 0 power right here. There you go. So how are we going to do this one? How are we going to simplify this? Of course, it's a more complicated one, right? So let me do the left one first, huh? Let me do the left one, then we do the right one. We try to simplify that. So 4 divided by 2, this is called coefficient. So I'm going to have I'll give you negative 2, right? Okay, let's just do one by one. So on the top, I think I'm going to keep it for the time being, because we don't have to simplify it right now over there. Actually, there's nothing to simplify on the top right now. The bottom, I just apply the second formula, right? So give you x to the 8, y to the 4, right? Go 2 times 2, and t to the negative 1. And over here on the second one, 5 simplify with 15, so you have 1 over 3, so 3 should be at the bottom. Okay, and this is give you t to the negative 4, right? Because negative 2 times 2, and x to the negative 3. And you have to be careful right here. You see, everything raised to the 0, so the whole thing raised to the 0. Okay, not everything, not just this part. You see that this part I put into parentheses. So actually this one turned out to be 1. So what we have left is just this, right? And this one is y to the negative 8. We apply the second formula. Alright, so right now, so we're going to simplify this negative 2, negative 8 right here. So to become negative 10, right? So to become negative 10, so we have negative 2 x to the negative 10, right? And negative 3 minus also with y to the negative 7, right? And 5 minus will be t to the 6, right? Time. Alright, so this one is y to the negative 8. Okay, this is y to the negative 8. So y to the negative. So I'm gonna put y to the negative 8 over here. Okay, y to the negative. Because this is multiplication, so I can go ahead and put y to negative 8 here, and I put everything over 3 t to negative 4. And x to the negative 3. Okay, now I'm going to apply again. Negative 2 and 3 is the coefficient. I'm going to just go ahead and keep it like that. Okay, we're not touching because it's not exponent. Now, x to the negative 10 over x to the negative 3, so my number is going to be x to the negative 7, right? Y to the negative 7, 1 to negative 8. So I'm going to apply the same base, multiply the same base over here to give you add them. So this is the third formula right here for the y to negatives and y negative. So we give you y to the negative 15, huh? And t6 minus 1 so will be t to the 10. There you go. Almost there. Now everything with negative exponent, we're going to flip it down, so we can negative 2 on the top. T to the 10 is on the top because it's positive. Alright, 3 is the denominator already, so it's on the denominator. Now become x to the 7 because it's turned out to be positive. y to the 15 turned out to be positive. Alright, good. Alright, so that's all. I think that's the complicated enough already. So you guys just need to be used to it. I mean, it's not hard. However, you have to apply all the property here, and you need to know when and where you should apply which one. Okay, as you see, that most of the time we apply the second one and the third one, right? And the fourth one. This is the very important. And this three formula here is super important. So we use this a lot. Let me right over here. Okay, but of course the other one is also important. You know, this one is here, next one, I'll say. All right. So some exponential expression is more complicated than the other one, and it requires more time to simplify. But I mean, the concept is still the same. It's just nothing hard. I mean, you just see this the same exponent, the same base, and you just apply them. But the most important thing is you still have to memorize all the property here, otherwise you cannot do it. All right. Alright, so I think that's all for exponential expression. I know that I've given you guys only 7 example, but if I give you more, then probably it take you guys a lot of time. The most important part is that you have to practice by yourself. Okay, and when you're doing homework, and if you have if you're struggling with the homework, and just send me a screenshot, and I'm very happy to help you guys with the homework problem. Okay, I'll see you guys next time.